Good evening, everyone. Am I audible? Very good evening, all. Very good evening, one and all. Am I audible? Please mention in the chat box, am I audible? I hope I'm audible right now. Good evening, everyone, and welcome back to our day 3 21 days masterclass series on autonomous vehicle. Am I audible, guys? Good evening, Akash, and good evening, Aditya, Gupta, very good evening, Sri, very good evening. Yeah, thank you. Thank you for your response. Very good evening, Onadal. I hope you are all doing well and had a productive day also. I welcome you all for engage your learning experience with Pantech eLearning anytime, anywhere, at any places. We are always supporting to the students in a technical way. So our main vision is to help the 10 million students easily learn the technology. So today is day 3 of 21 days masterclass series on autonomous vehicle. Good evening, Sanjay Khanna, good evening. Yeah, Akash, good evening. Raj Kumar, very good evening all. So today we are going to talk about something interesting about the masterclass. So first, that is day 3, visualizing sensor coverage detection and tracks. So this is the today's topic. So sensor coverage. So what is a sensor coverage? So imagine, yeah, very good evening, Sanjay Khanna and Anand, very good evening. So what is the sensor coverage? So sensor coverage in the sense, imagine drawing a big circle on a map to show where the sensors are looking. That is what the sensor coverage. So next one is the detection. What is the detection? So it's like putting some dots on that map to show where the sensors find interesting things like the peoples or a cars or a bicycle, anything on the road. So they have to detect. Yeah, good evening, Ravi Kumar. Very good evening, Prashant. And then move on to the tracks. So what is the tracks? When those things move, we draw some lines to connect that dots and see what they are going. It's like tracing their path on the map. That is what the today's topic we are going to discuss about the visualizing the sensor coverage and detection and tracks. First, so this is the bird's eye plot. So do you have any idea about this? Shri Krishna Electronics, very good evening. Shantanu Shukla, good evening, very good evening all. So do you have any idea about this plot? What is this bird's eye plot? Before we enter into that sensor coverage, so first we have to know what is this bird's eye plot? Yeah, good evening Santoshi, very good evening. Do you have any idea about this bird's eye plot? Please comment your answer in the chat box. Do you have any idea about this bird's eye plot? What is it, bird's eye plot? What we have to do in this plot? So I will tell you the answer. So in this example, we are going to look at how we can use this plot, how we can use this bird eye plot in MATLAB to show something happening around a car. So imagine you are, yeah, very good Akash, it's a visual sensor. So imagine you are sitting inside a car and you want to see what's happening around that car or around you. So that's exactly what we are going to do with this plot. So first of all, we have some information about the lanes on the road. So we have some information about the lanes on the road and we will draw those lines on our plot to give us a sense of where the car is driving. So next we have here we have two types of sensors our car. So first one is the vision sensor, another one is the radar sensor. So these sensors can help the car to see and what's around it. So here the vision sensors are the eyes of our human eye. So radar sensors is like a yes, but they can help the car understand its surroundings. Now we have got some data from these sensors. The vision sensors have spotted some objects and the radar sensors have detected the other objects. So by using this bird's eye plot, we will show these objects on our plot as a dot format. And one more thing, we are also tracking some of these objects over the time also. Here we will draw the lines to show where these objects have been and where they are going like that. So now all this information is being shown on the one plot that is called bird's eye plot. So all this visual information is being shown on the one plot, under this one plot that is called bird's eye plot. So it's like a special map that help us understand what's happening around the car. So with this plot, we can get a clear picture of what's happening around the car. So in this example, today we are going to explore how a car can understand its surroundings by using some pre-recorded sensor data and tracking the results also. So this is the bird's eye plot. And next one, now we are going to plotting our tracks in the lane or in the road. So this is that plotting the tracks. And next one is the final output. So finally, we have to create this bird's eye plot. Here you can see the vision detection and radar detection and tracked objects in the square and history is in the small dot and most important objects. So here what we have. So the final output, here we get the lane information. So we know where the lanes are on the road. So you know those lines that help you stay in your lane. Here you can see this yellow color line is a lane boundaries. So we have that information by using this bird's eye plot. Next one is the vision object. So that means vision detection. Here you can see this is the vision objects. So we have data from the special vision sensors. So these sensors, it's work like our eyes. It can spotting the objects around the car. So next one is the small circle. Red small circle is the radar detection. So these are all the radar sensors on the car. It can detect objects by bouncing the signals of them. So next one, we are keeping track of some of these objects over the time. We know where they are and how fast they are moving and even how certain we are about their position. So we also give them labels so we can tell exactly. So here this black color square, that is the most important object. That means there is a one object we are particularly interested in. So it could be something a big car or it could be something a moving fast car. So whatever it is, we have to track that one also. So all this information was recorded quickly. It updates 20 per second of the most things. So except for the vision detection, so which were recorded at the 10 updates per second. So what we are going to do with all this data? So we will use some special kind of the plot that is called bird's eye plot to visualize it. That means this plot is like a bird's eye view of the environment around the car. So that is why we use this plot. So we directly get into the MATLAB software demo. So for that, first we need the MATLAB software. So I am opening this MATLAB software home page. Here you can see. So how many of you know about the MATLAB software before? Do you have any idea about what is this software and what we are doing this software, especially for the autonomous vehicle? Do you have any idea about that? Otherwise, I will explain you. So how many of you know about this MATLAB software? Please comment your answer in the chat box. How many of you already know about this MATLAB software? Yeah, Jayanti, the coordinator will contact you. Okay. So we know the MATLAB is a software that is used for the programming and analyzing the data also. Yeah, okay, Mihira, I will explain. So basically, this is the MATLAB software homepage. So it's look like this only. So this MATLAB, yeah, we can do simulation in MATLAB also. I will explain you. MATLAB is a software that is used for the programming and analyzing the data. It is commonly used for the autonomous vehicle because it helps in developing and testing the algorithms for tasks like sensing the environment and making the decisions and controlling the vehicle's movement. So it's a very popular software because it's offer the many tools. So simulation, modeling, and data analysis, and so these are all the things make it easier to create and improve the autonomous system. So this is what the MATLAB software, and in this MATLAB software, here you can see this is the, yeah, we can make a model and simulate in a simulation also. So this is the home page of the MATLAB software. So first you have to know this is the command window. So what is this command window? In the sense, it's a command window. It's where you interact directly with the MATLAB software. So you can type commands here. So that MATLAB, it executes them immediately and showing the results. So it's like having a conversation with the MATLAB. So that telling it what to do and getting the instant responses. That is what the command window. Next, here you can see the current folder. So this is the current folder, and this current folder is the directory where the MATLAB files. MATLAB look for the files to work with when you open or save the files in a MATLAB. So it is a default to this folder. So next one is the workspace, and here workspace, wait, I will show you that workspace also. So just type the workspace. Yeah, so this is the workspace. In this workspace is where MATLAB stores all the variables and data you create or you import. So it's like a storage area where MATLAB keeps a track of everything you working on the command window. You can see the content of the workspace in the MATLAB desktop. So this is the workspace. Now we are going into the MATLAB script. So just clear this command. I am going to type the edit. So this is the MATLAB editor page. That means MATLAB script. Here we have to do the script. I'm going to talk in this. So this is the MATLAB script. So basically the MATLAB script is a file that containing the sequence of MATLAB commands that you can run together. So it's like we can do the program in the MATLAB script. You can create the script to automate the task or perform the calculations without typing the same commands repeatedly. So this is what the script, that means editor page. So basically why we use a MATLAB script, in the sense we use a MATLAB script to automate the task, perform the calculations or execute a series of commands without needing to type them repeatedly into the command window. So that is what the MATLAB script. So now I am going to create the bird's eye plot by using this editor page. Okay, so let's do this one. Yeah, MATLAB is not a free version, Sahil. So is there an online version for a 1 month? Free online version, so 1 month is available. So you can directly download that version. No. So online version is a free online version available in the MATLAB software. You can directly download that version. So now we are going to create the bird's eye plot. So first step is we have to setting the coordinate here. So just open the MATLAB software and open this editor page. So here you can see, here we are going to type the command. We are going to type the program here. So for that we have to create our First, we have to create our setting the coordinate. So now I am going to setting the coordinate. So for that, just I am putting the command using this percentage symbol. So setting the coordinate. So first I am going to setting the coordinate. So just type the command. So recent version or 2022 B version you can use. So first I am going to setting the coordinate. So first I am going to use this BEP, that means bird's eye plot function, giving the space and type the bird's eye plot function and open this one. So here we have to create the X limit and Y limit. So I am going to create the X limits and comma, give the space, open the square braces, the 0 space 90. I will tell you once I finish this one. First line. So first we have to create our bird's eye plot, comma, and again give the space, and this is the Y limits, and place the comma and give the space and open the braces. So this one is minus 35 space 2 plus 35. So this is the X limit and Y limits. Now ended up with the semicolon. So now I am telling that meaning. So here we are creating the coordinate. So first we have to setting the coordinate. So in the first step, we are going to configuring our bird's eye plot. We are setting the coordinate system. So imagine you are looking at the scene from above the car. So we are going to create that view with the x-axis and y-axis. So now we need to decide how far we want to see. So in this example, we are focusing on what's in front of the car. So we are setting the limit to 90. X limit is 90 meters ahead of the car, and we also want to see what's around the car. So in this car, we will set the limit to 35 meters, that is 35 meters on the each side. So we also want to see what's around the car. So that is why we create a coordinate. So this means our bird's eye plot will show as a square area with the sides of the 70 meters. That means 35 meters on the each side, and depth is 90 meters in front of the car. So this gives us a good view of the scene around the ego vehicle. So once you have set up the coordinate system and define the scene limits, we are ready for the next step. So which is to add the sensor coverage and plot data onto our bird's eye plot. So now I am going to create the second step. So for that I am going to use that function name is cap I. So that function name is cap of. So Mehir, don't worry, I will teach you. So this is the basic program only, so not that much difficult. So I will explain every line, okay? Don't worry. So cap of 1, give the space, and so coverage. So I am using the coverage area plotter. I will explain what is this coverage area plotter and what other types of plotters also available. So wait, I will show you. Yeah. So first we have to set up the setting coordinate, that is the first line BEP. Next we have to create this what is this? Next we have to create this coverage area plotter. So basically there are a lot of plotters available, and this coverage area plotter, this plotter is used to visualize the sensor coverage area. So it helps us see where the sensors can see in the environment. So that is what the coverage area plotter. So there is another plotter also. So I will show you that detection plotter. So just to type the help space direction plotter. Direction plotter. So press the enter. Wait. Help. Direction plotter. So once you enter this help detection plotter, you will get the information about that plotter. So I will tell you the four types of plotter. So first one is the coverage plotter and another one is the, wait, I am going to write this one. So first one is the coverage area plotter and another one is the direction plotter and another one is the track plotter. So this is the track plotter. And first coverage area plotter is used to visualize the sensor coverage area. It helps us see where the sensors can see in the environment. So that is what coverage area plotter. Next one is the detection plotter. So this detection plotter, it helps to visualize the object detections that made by the sensors. So it's shown us where the sensors have spotted the objects. And next one is the track plotter. So mainly this plotter is used to visualize the tracks. It helps us to track the objects over the time. That is what the track plotter. So another two plotters also will be there. That is the lane boundary, the path plotter. So lane boundary in the sense that is used to visualize the lane boundaries on the road. Path plotter mainly is used to visualize the object trajectories. So this is the different types of plotters. Now we get into that topic. So this is the cap of 1. So here you can see this cap of 1 in the sense. So first we have to use this coverage area plotter, 1 for the vision sensor and 2 for the radar modes, and we are specifying the color of the coverage area to differentiate between them. So that is why we use this blue color. So the face color, that means the face color. So this face color parameter, it sets the color of the coverage area, and edge color parameter, it sets the boundary of the coverage area. So face color, it sets the color of the coverage area, and edge color, it sets the boundary of the coverage area. So next, the cap of 1. So what is this cap of 1? Here this line, it creates a coverage area plot and assigned to the variable cap 1. So this is like a variable, and we are going to create the coverage area plotter and assign to the value to cap 1. So this is coverage area plotter is a kind of the function used to generate the plot. And next one is the BEP. It's like a parameter that specifies the bird's eye plot object or the data. And next one, face color, the blue face color, that means it sets the color of the coverage area to the blue. And edge area, that is the color of the coverage area edges to the blue color. Then again cap of 2. So this is the another variable, and this variable is for our radar sensors. So that is why we mentioned that one. So again we are going to load one configuration here. So that configuration is called loading the sensor configuration data in a MAT format. So mainly this load format, this load function, this line loads the sensor function data from the file named sensor configuration data.mat file. So this file contains the information about the sensors. So what are the information inside this sensors in the sense? It has a positions, it has a ranges, and it has a yaw angle, and it has a field of view also. So these are all the information we can get from this sensor configuration data.mat. So we are going to load this one. So before we enter into the for loop, I will share one detail to you. So if you are interested, you can convert the Masterclass in this autonomous vehicle to 1 month internship. So basically you will get this internship. During this internship, what are the benefits you will get? You will get the 30 days of live sessions and 90 days of recorded content and 90 days of access to recorded content and 10 plus source code for the EV projects. Abhi, yeah, this is the default configuration data in the MATLAB. So you can get the 30 downloadable presentation and internship certification. So the actual price is 1,999 and we are giving the discounted fees, that is a 699, using this registration link. So join as an internship user. If you really want this autonomous vehicle, you can convert this 21 days masterclass into 1 month internship. So 30 days internship. So additional 9 days you will get the new one. Yeah, Jayanti, definitely the Am I audible right now? Am I audible right now? Yeah, sorry for the interrupt. Here I'm having a network issue. Am I audible? Yeah, thank you. Am I audible? Yeah, thank you, Mihir. Thank you. So, this is the registration link for the autonomous vehicle internship. And one more thing, we are providing the exclusive offer, that is 3-in-1 internship offer. In this internship offer, you will get 3 big masterclass. First one is EV design and MATLAB Simulink and autonomous vehicle. So you are getting these 3 big masterclass in this exclusive offer. So that is the actual price is 4,997, and we are providing the discounted fees, that is 999. So use this registration link, join as an internship user. So what you will get, this exclusive internship offer, you will get the 120 records, 120 self-paced records and weekly live sessions and 3 internship certificates and 1 month internship certification also. You will get 20 plus project belong to this big domain, EV design and MATLAB Simulink and what is it? Autonomous vehicle. So you will get downloadable presentation and internship confirmation letter, and you will have weekly hackathon sessions. That means doubt session. So the actual price is 4,997, and we are providing the discounted fees, the 999. Using this registration link, join as an internship user. Yeah. So don't miss out this opportunity. It's not only budget friendly, it gives you access to valuable knowledge and mentorship and hands-on experience also. So this discounted fees during this 21 days live class only. So after this, we are not giving this price. Yeah. So let's go back to our program here. So first we have to setting the coordinate, and then we are going to load this sensor configuration data, and now we are going to create the for loop. So for this loop, so first we have to initialize so we use some loop. So we use a loop to iterate over the each sensor configuration. So that is why we mentioning this one, that is the plot coverage area Inside this function, we have a cap of I and sensor parameters, and sensor parameter X and sensor parameter Y and sensor parameter range. So in offline, you will have the doubt session and also you will get the 9 days. So this live class only for 21 days, but in the internship, you will get additional 9 days, and that 9 days you will get the additional projects. So that is the differentiate between this 21 days live session and 1 month internship. So inside this plot coverage area, you will have the cap I. So this refers to the coverage area plotted object that we created earlier. So here we are using this object to plot the coverage area for the each sensor. So X and Y, and it represents the position of the sensor that is related to the axis region. So X and Y coordinates respectively. So next one is the range. So what is that range? So range is it indicating how far it can see. Next one is the yaw angle. So what is this yaw angle? So this yaw angle, it's related to the x-axis. That means it's specifying its orientation. Next one is the field of view. As I said earlier, the field of view of the sensor is indicating angular range over which it can detect the objects. So inside this plot coverage area loop, this is a function. It is called to plot the coverage area for the each sensor. So this function, it takes the sensor's position, range and yaw angle and field of view as the input parameters. So next I am going to add the title of this plot. So what is the title? We are using the title function. Inside this title function, we are going to name that plot, that is the bird's eye plot. So this is the meaning of this title function. And next we are going to load the another data. So what is that data? So this code, it loads a MATLAB file. That name is called bird's eye plot example data.mat format. And this one, it specifically retrieves the variable data to display from it. So this variable is likely contains the information about the environment that's surrounding a vehicle that captured by the sensor. And now we have to selecting the time step. So here I am giving the time step to 125. That means it sets the time step to 125, it indicating a specific moment in the recorded data. Again, we are going to extract the data. So that is the reason of this data for times step. That means we are going to extracting the data for the selected time step. So this meaning, in the sense, this line meaning data for time step equal to data to display. So it retrieves the data corresponding to the selected time step. That means a 125 from the loaded variable. So what is our loaded variable? From the loaded variable to data to display. So this is called a loaded variable. So these subsequent lines, vision object pose and radar objects and lane boundaries and track productions, track positions and track velocities and track covariances and track labels. So these are all the positions of the object that detected by the vision sensor, and another one is the radar sensor, and then lane boundaries of the road and track positions, in the sense that positions of the tracked objects. Track velocity means velocities of tracked object. Next one is the MIO label. So that means it's a label or it's an identifier for the most important object. And next one is the MIO position. So this position of the most important object position. Yeah, thank you for your valuable comment, Bharat Singh. So next one is the velocity. So it's velocity of the most important object. So mainly this code, it prepares the specific data for analysis. It's likely aimed at understanding the environment around the vehicle at the selected time step, such as detecting the objects and tracking their movements and identifying the important objects. So this is all that the data to display function. Now we are going to plotting the detections. So how we plotting the detections? We use some variable here that is called BEP plotter.vision. So here you can see this BEP plotter.vision. This line, it creates vision detection plotter and store it in a structured name that is called BEP plotters.vision. Next one is the display name. Display name. So this display name parameter sets the display name of the plotter to vision detection. So next we have to initialize the marker edge color. That means this parameter, it sets the color of the marker edges to the blue one. And this marker parameter, it specifies the marker style for the detections as a upward pointing triangle. So that is why we mentioning that one. And the same way, again we are going to creating the same radar detection plotter by using this BEP plotters.radar. Again we go to the plotting vision detection. So that is why plot detection BEP plotters.vision, that is one for the vision object, and the same that is one for the radar object pass. Now we are going to detecting the BEP plotters track. We are going to track plotting the tracks and plotting the most important objects. So that is why we use that function here. So in this line, it creates a plotter for displaying tracked objects on the bird's eye plot. So the same, the display name parameter sets the name of the plotter to the tracked object. The history depth parameter, it specifies the number of the tracks. That means history to display. In this case, it's set to the 10. And next one, creating the plotter for the most important object. So MIO, most important object. The same way, the display name sets a parameter, sets a display name of the plotter to most important object. So at last we have to create the plotting talks for the lane boundaries also. So the same way here we are going to create the lane boundaries by using this BEP plotters function. Now I'm going to run this code. So do you have any doubt in this? Shall I run this code? Do you have any doubt? If you have any doubt, please mention in the chat box. I will explain you. So this is the way you have to create your bird's eye plot. Shall I run this code? Let's see what will happen. Let's see this census information, it detect or not. So this code is only for the internship users, Divya. If you need the internship user, you can join by using this code registration link. So if you want only the autonomous vehicle masterclass, directly use that. Yeah, okay. So I am going to run this code here. So this is the output. It clearly see. So this is this indicator. This is a small triangle. It will give the introduction. It will give the information about the vision detection, and the small circle, red color circle, it will detect the radar. So Prasad, MIO, in the sense that is the most important objects. So that is a moving object or a big car or a big truck like that. So here you can see the lane boundaries also it detected, and most important object is this symbol, and again this is the tracked object, that means a moving object, and lane boundaries and history. So this is the output of this one. Again I am going to run. You can clearly see. So first we have to create the angle of the sensor, one for camera and another two for the radar. So this is the output of this sensor coverage and bird's eye plot. So okay. So overall this code segment, it creates a plotter for displaying the lane boundaries and vision detections and radar detections and most important objects like that. So this allows you to visualize the road. Do you have any doubt in this? Yeah. So this is your task. So you have to examine the bird's eye plot. You have to create the bird's eye plot by displaying the sensor coverage and detections and tracks and lane boundaries around the ego vehicle. So you focus only the any one of the sensor, any vision sensor or radar sensor that displayed on the plot. So this is your task. Okay, do you have any doubts? So before we wind up the session, I will give you the short introduction about this internship also. You can convert this masterclass into the 1 month internship. So during this internship, you will get 30 days of live sessions and 90 days access to recorded content. And also you will have weekly hackathon sessions, that means doubt clarification sessions. Now we are providing another one more exclusive offer, that is a 999. You will get 3 big masterclass under this exclusive offer. So that price is 999. If you want only autonomous vehicle masterclass, that is 699. So this most important object data, that is pre-built in our sensor configuration data, Prasad. So here you can see. So these are all the information. These are all the. So Ram Mogan, this code is only for the internship user. If you really want the internship, you can convert this masterclass into 1 month internship. So here you can see that load sensor configuration data. So basically this subsequent data. So inside this load bird's eye plot example data, inside this data, we have to load a recorded data from the MATLAB file, and it extracts the information about the environment surrounding the vehicle at a specific time step. So this loaded data likely includes information captured by the vision and radar sensors based on the configuration. So what are the extracted data variables? So that is why we mentioned here vision objects and radar objects and lane boundaries and track positions. So for example, vision object pose, it's likely contain the positions of the objects detected by the vision sensor. So Mr. MS, here you have the registration link. So this is the registration link. If you really want this masterclass into 1 month internship, you will use this registration link to join as an internship user. So for example, it's like a radar object pose. It's likely contain the positions about the object detected by the radar sensor. So that is aligned with the radar sensors and some configuration detail. So this code, it processes the recorded sensor data only and the provided sensor configuration that provide a context for understanding the data being analyzed. So this extracted data variables in the code, it's likely correspond to the sensor data that captured based on the configurations of the vision and radar sensor. So this is all about today's session. Do you have any doubt? This is your task. So this is your task. So you have to create the bird's eye plot and displaying the sensor coverage and sensor detections and tracks. So focus any one type of the detection. That means a vision or a radar. So you have to focus only one. So that is easy to plot some things. Yeah, Mihir, we will provide the code to only the internship users. So before we wind up the session, I will conclude the session, today's session. So today we visualized the surrounding environment of a vehicle by using the bird's eye plot. So we configured the coverage areas and representing the sensing range of visions and radar sensors. So by loading a recorded sensor data and we plotted the detections based on that. And also we plotted the detections, we plotted the tracks of objects, including the most important objects also. So this is all about today's session. Do you have any doubt? Please mention in the chat box. Otherwise, we will wind up the session. Yeah, Govind, internship users, you will get the link, software link. This is all about today's session. How was the session? I hope everyone can understand this one. So don't miss out this tomorrow's session because tomorrow we have a ground truth labeler app overview on how to create the label and how to import the video into the ground truth labeler app. So don't miss out tomorrow's class. Yeah, thank you, Govind. Thank you. So if you really like the session, give the heart in the comment box. Thank you so much. Thanks to everyone. Thank you all. Thank you for your active participation also. Yeah, Miguel, you join a internship. I will clarify the doubts regarding a coding. Yeah, thank you so much. Thank you all. We will meet tomorrow. Thank you. Thank you, Bharatraj Singh. Thank you, Sonu Singh. Thank you. Thank you, Durga. Thank you, Venkadar. Thank you, Mihir. Yeah, definitely. I will share that code, Mihir. Yeah, thank you, Prasad. So, internship students, you will have weekly hackathon sessions. That means doubt clarification sessions. Yeah, thank you so much. Thank you. Thank you all.